Algebra 2 concept students. So this video is talking about absolute value inequalities. And to do this, we're going to review a little bit what we did with an absolute value equation. And remember, when the absolute value of x is equal to 3, this meant that the distance from 0 was equal to 3. And so therefore, those numbers that have a distance of 3 from 0 are 3 and negative 3. And so when we solved an absolute value equation, for example, like the absolute value of 2x plus 1 is equal to 5, we isolated that and we rewrote it as 2x plus 1 is 5 and 2x plus 1 is equal to negative 5. And then we solved both of those equations. So very similar with absolute value inequalities. When we have the absolute value of x is less than 3, this again means the distance from 0 is less than 3. That means we are talking about everything on a number line between 3 and negative 3. So it would be everything in between here has a distance from 0 less than 3. All right, now we've also learned in our last video that this is a tweener. And this could be written as x is between negative 3 and 3. So when we have any absolute value inequality, and it's less than, we know this is a tweener. And I could rewrite this as 3x minus 1 is between negative 4 and positive 4. And then I would solve this just like we did in the previous video. If the absolute value of x is greater than 3, now again we're talking about this distance from 0 being more than 3. So we're talking about numbers that are a distance of 3 or more from 0, either direction. And you can see this is a splitter, which means that x is less than negative 3 or x is greater than 3. And so if you have an absolute value inequality that's greater than, you're going to rewrite as an or statement. You're going to write as 3x minus 1 is less than or a negative 4, or 3x minus 1 is greater than 4. And then you would solve each individual inequality. So remember that anytime you're dealing with absolute value, you will isolate and rewrite. If it is a less than, you're going to rewrite this as a tweener. If it's greater than, you're going to write it as a splitter, as an or statement. All right, some examples. And these are kind of coming from the study guide, page 38. If I asked you to solve this absolute value inequality, I would look at this and make sure this is isolated, which it is. And it is a less than symbol. So I know that I'm going to rewrite this. I'm going to put 3x plus 4 between negative 8 and a positive 8. And then, like I did in the previous video, I'm going to subtract 4 from all 3 parts. I'm going to divide all 3 parts by 3. And x is going to be between negative 4 and 4/3. I'd have an open dot at negative 4. an open dot at 4/3, and everything in between there. The next example is absolute value. It's less than. I'm going to rewrite this as a tweener, putting 5w plus 2 between negative 28 and positive 28. And then, again, solve it the same way.
Green team all cleared, green team all cleared.
And then I'm going to divide by 5. I'm going to get w to between negative 6 and 26/5, which would be like 5 and 1/5. Graph's going to be a tweener. It was just less than, not equal to, so it's open dots, everything in between there. This next example now is greater than. It's greater than or equal to 30. So this is going to be a splitter. So I'm going to rewrite this as, and it is isolated, so I'm going to write it as a plus 9. And then I'm going to switch it to less than or equal to and switch it to negative 30. Or, and then just write it the way it is without the absolute value symbol. A plus 9 is greater than or equal to 30. I'd subtract 9. I'm going to get a to be less than or equal to a negative 31. I would subtract 9 over here and get a to be greater than or equal to positive 21. This graph is going to be equal to, so closed dot less than that, closed dot at 21, and everything to the right of that. And then the next example, this is not isolated. So the first thing I would do would be to subtract 3. Now I have the absolute value of 4b minus 11 is less than 17. And this is a less than problem. So I would rewrite this as a tweener, putting 4b minus 11 between negative 17 and 17. Going to add 11 to all three parts. Divide everything by 4. And now I've got reducing. B is between negative 3/2 and 7. Which again, the graph would look like a tweener. Open dots and everything in between. So hopefully this realizes if it's an absolute value inequality, you're basically going to rewrite it as a compound inequality and then solve. Isolate and rewrite. So this, once you get done viewing this video, you should be able to do problems 7 through 10 there on the 1.6 practice.